In the previous video, we saw that if you have a nice ordered list, the binary search is a great way to locate an item in that list. But what if your data isn't sorted? Well, the thing you do is you sort the data. In this video, I'm going to show you two of the classic computer science sorting algorithms. So we'll look at the bubble sort, and we'll also look at the selection sort. What I have on screen is, first of all, I've covered up this thing. So there we go. That whole thing's covered up, and I'll now explain why as we go along. But let's suppose we just start out with a list of numbers. So here on the left side, you see we have some numbers that are not sorted. And I'm going to use the bubble sort to sort them. What I'm going to do first is to explain how the bubble sort works. Then I'm going to explain how the selection sort works. And then we'll look at the actual code, the C++ code that implements these sorts. Now, the bubble sort, it's shown here. And the way that it works is it starts at the top or the lowest index, and it compares the two numbers that are highlighted here with the background of gray and the color in red, the color of the numbers in red. So it's going to go through these numbers, comparing them pairwise, one after another, and if we're sorting in ascending order, then it will swap them. So in this case, it begins by comparing the 9 and the 5. And if we're going in ascending order, you know, the 5 should be at the top and the 9 should be next. So what it does is it will compare those two and it will interchange them. So after comparing those two numbers, then the order of the numbers is shown here. So the 5 now has been moved up and the 9 has been moved down. The bubble sort then proceeds by just increasing the index by 1, and it compares the next two numbers in the list. So in this case, it's comparing the 9 and the 2. And it compares them, and it finds that the 2 is less than 9, so it interchanges those two. So the 2 and the 9 are going to change places, and that's shown here. Okay, so the 2 is now at the second spot, the 9 is at the third. And then the index is increased, and we move down and we compare the next two numbers. So this is how it proceeds as we go all the way through the list. So the 9 and the 4, those are compared. 4 is less than 9, so those are swapped. And then we have the order of the numbers that are shown here. So the smaller numbers are moving toward the top, and the larger numbers are moving toward the bottom as we go through this, and that's how it gets its name. The numbers are kind of bubbling up from the bottom towards the top into the small numbers. So it's called the bubble sort. Anyway, moving along, we compare the 9 with the 7. 7 is less than 9, so those are interchanged. And now the order of the numbers looks like this. And then we move down one index. We compare the 9 and the 8. So you can see that the shaded cells show you what's being compared. Okay, once again, 8's less than 9, so those are swapped. And the 8 is placed above the 9, and the 9's gradually making its way down. And we're almost to the bottom. Okay, so after comparing 8 and 9, we compare the 9 with the 1. 1's less than 9, so those are swapped. And then finally, we compare the 9 and the 6, and since 9's the largest of the set of numbers we have, then those are interchanged. The 6 goes up, the 9 goes down, and that constitutes one pass. So you can view this as a nested loop. So as we're moving from left to right along these columns, then we have to pass through those numbers, comparing them pairwise over and over again. So we have an inside loop that we have an internal loop that does the comparisons. We have another loop that's going to do the passes. So obviously, then when we get to this last column, those numbers are not sorted yet. So the way the bubble sort works is it takes this set of numbers on the right and it starts all over again. So now this is pass number 2. So we start with a set of numbers that we just finished in pass 1, and the bubble sort does the same sort of thing. It just compares the two numbers pairwise, starting back at index 0, and the 2 is less than the 5, so it moves up, the 5 moves down. Then the 5 is compared with the 4, so the 4 moves up and the 5 moves down. But it always compares them adjacently. It just compares two numbers that are adjacent to each other in the list. Okay, so 5 and 7, those are okay. Okay, so 5 is less than 7. So in this case, there's no swapping that takes place here. Then we just proceed to the next pair of numbers, the 7 and the 8. And 7 is less than 8, so there's no change there either. So then we just move on and we compare the 8 and the 1. And then, of course, that 1 is less than 8, so those are swapped. And now the 1 moves up above the 8 moves down. Then we up the index, we compare 8 and 6. 6 is less than 8, so those are interchanged. And then we have finally the 8 and 9, and those are okay. 8 is less than 9, so no interchange takes place, no swapping. And so after 2 passes, we have the column on the far right. So this gradually sorts the numbers. Now, you see the process, so I'm just going to show you these other passes and not go into it in so much detail. Okay, so here's pass number 3. So as we move across, you can see the same thing happening, but the numbers are getting better and better. They're almost sorted and getting better as we go on. So the 2 and the 4, okay, those are okay. The 4 and the 5, they're okay. 5 and the 7, no swapping needed. But then when we compare the 7 and the 1, of course, we swap the 1 and the 7. Then the 7 and the 6 moves up, 7 moves down. Then we compare the 7 and the 8 and the 9. No swapping is required, so then we're finished with pass number 3. Okay, then we continue. We keep going through these passes over and over again, and I'm just going to remove that for right now. Okay, so pass number 4, we take the column from the far right from the previous pass, and we go through them once again. Okay, so we compare them pairwise, and the everything's in place pretty much except the 1. So the 5 and the 1, when you compare those, you swap them, the 1 moves up. The 5 and 6, no swap. 6, 7, no swap. 7, 8, no swap. 8, 9, no swap. And then we're on the far right column again, and the numbers are almost sorted. Okay, past number 5, we get even better. Okay, the number 1 is still moving up. Okay, first test, 2, 4, no change. We compare the 4 and the 1. We do make a swap. 1 goes up, 4 goes down. And then as we compare them pairwise from left to right, then the 4 and the 5, those are okay. 5, 6, they're sorted. 6, 7, 7, 8, 8, 9. And then finally we make it to the right again. Now, even though these numbers now are mostly sorted, the bubble sort still does all those comparisons. Okay, so the 5 and the 6, compared them, 6, 7, 7, 8, 8, 9. So it does go through the loop, and it does make all these comparisons. By the time we move through pass number 6, and let me get that all on the same page. So here's pass number 6. So everything's in place except the 1 and the 2. So we compare 2 and 1. Those, the 1's less than 2, so we swap them. And now the numbers are sorted. Once you see this column here, the numbers are sorted, but the algorithm isn't finished yet. So it will continue to compare these pairwise, 2, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9. It goes through the loop and continues to compare those. And even though now after pass 6, we have all the numbers sorted. That's the bubble sort. The number of passes, I'm stopping here, but the number of passes that the bubble sort makes is equal to the number of items in our list. So we have 2, 4, 6, 8. We really have 8 numbers in the list. So there's also a pass 7 and a pass 8 that will take place, even though I'm not going to show you the details of that. So that's how the bubble sort works. And you can see it does sort the numbers, but you can also probably guess that there must be a better way. The bubble sort isn't that efficient. So let's look at a second sorting algorithm, which will do a much better job. This is called the selection sort, and here you can see the whole thing, but let me cover up the columns and we'll look at them one at a time. On the far left, I've indicated the index of the array. So element 0 contains 9, 1 contains 5, all the way down to 7. So we have the index plus we have the numbers. Now, the way the selection sort works is as follows. It tries to find the minimum value in the list, and it places it up at the top. So in the selection sort during the first pass, we start at index number 0, and we take whatever number is there, and we're going to swap it with the minimum value in the list. So there's a search that goes on. The number 9 and all the rest of these numbers, we check the whole list to find the minimum value. So of course number 1 is the smallest number in the list. It has index 6. We want to put it at the top. Well, the number 9 is at index 0. So we end up swapping those two. So when I move that over, then the number 1 is placed at the top, and to make room for it, the number 9 goes down here where the number 1 was previously. So it goes into index 6. The number 1 goes to index 0. Now, the other thing here is that now the smallest number is at index 0. It's at the top. So we do not need to move it. We don't need to check it any further. So the next pass through, we're just going to look at the remaining numbers, the 5, 2, 4, 7, 8, 9, and 6. So we're going to now look at the number that's at index number 1, and we're going to search through the list to find the minimum value a second time. Well, in this case, the next smallest value is 2. So we want to interchange the 2 and the 5. So the index of the smallest number, 2, is also index number 2. And we want to interchange that with the item at the top of the list, which is now 5. Okay, so when I've covered this yellow, that means we're not going to consider that index anymore because it contains the smallest value. So let's move over. And now the 2 is going to be placed here, and it's in its final location. We don't want to move it again. And the 5 is going to be moved down to index number 2. Then we repeat the process, but we only look at the remaining numbers. We don't look at the index 0 or 1. We start with index number 2. And we look for the smallest number in the list. The smallest number now is at 4. So we want to interchange the numbers at index 3 and index 2. When we do that, then the 4 moves up, the 5 moves down, and the first 3 numbers are sorted. 1, 2, and 4, those are where they're supposed to be. So as the selection sort continues through its passes, then it's going to place these numbers in their final location, and then it reduces the number of items we need to search as we go from left to right. So in pass number 4, the item at index 3 is going to be interchanged with the minimum value. Well, as it turns out this time, the number 5 is the smallest value, so nothing happens. I've got this shaded down here, the number 6, so that really shouldn't be shaded. But the number 5 there is sorted at its location, so it's not going to change. There's no swap necessary. Okay, so moving on to the next pass, then the 5 is where it needs to be. We move down, and we have 7 now at the top of our shortened list at index 4, and we locate the minimum value 6. Okay, so the index of 6 is 7. Index 7 down here contains 6. So we just interchange the item at index 4 and the item at index 7. And now that one has been placed. So this is repeated until we get all the way through the list. Okay, so now we've placed 6 of the numbers. 1, 2, 3, 4, 5 of the numbers. And then we have 8 at the top of the list. The minimum value is 7. So we want to swap those. And when we do that, the 7 goes to its final location, and the 8 goes to the bottom. Then we only have 2 numbers left. So 9 now is at index 6, and 8 is at index 7. 8 is less than 9, so we swap those, and we have the sorted list. So once we have sorted all the way down to that next to last number, then we are finished with the sort. And here you see the sorted list on the far right. So the selection sort is able to accomplish the sorting without having as many tests as the bubble sort, because it doesn't do a pairwise comparison every time. It finds the smallest value and it swaps it with the item at the top of the list, and then it finds the next smallest value and it swaps that, and so on. So this selection sort is going to be much more efficient as far as the number of if tests that it has to do and the number of swaps that it has to do. Well, there's a pictorial or a diagrammatic, I guess, example of how these two sorting algorithms work. The next thing now is to look at the C++ code to implement them. So let's look at the code to do that. Now here's the example, and there's quite a bit of code here already. So I have a constant unsigned integer size, which is 300, and that's a little big for the example here. So we're not going to sort 300 numbers, so let's just change that to 100 to begin with. And I'm going to use two functions that I've already shown you in previous videos. We are going to initialize the array with some random numbers, and then we will print the array out. All right, so as we move through the code, I've called this array1. It's just an integer, and I use the constant, so that'll be 100, and I've initialized there everything to 0. I call the init array function, and it will initialize that array to numbers from 0 to 99, so just like we did in a previous video. Then I'm going to print out the unsorted data. So I'll print out the, selection sort is not the one I want to start with here. I want to print out the bubble sort to begin with. So let's edit that to change that from selection sort to bubble sort. Okay, so I changed that to bubble sort. And I'll call print array to print out the original unsorted data. Now, just briefly, let's go look at those two functions. The init array function is here, so it just takes in a one-dimensional array, the number of elements it has, and it uses our random number generator to generate values between 0 and 99. So this is exactly the same function that I did previously. And also with the print array, we just have the array that we pass in. We pass in how big it is. And if I'm printing out the numbers, I'm also going to pass the width in, so I can do a set width here inside the loop that prints out all the elements. So simple, a couple of little simple functions I'm going to reuse. So the main thing that we need then is we just need to add the code for the bubble sort. So the bubble sort, let's just look at the solution. Let's look at the complete function and go through that and see how it works. So here's the code for the bubble sort. Now, one reason I'm not trying to work this out line by line is because this is a classic algorithm in computer science, and you can look up the code for this very easily just by Googling bubble sort or get it from almost any of your C or C++ reference locations or websites. Anyway, but let's go through it. So the bubble sort is going to accept an array that in this case contains integers, and I'm going to pass in how many elements there are in the array. All right, so this then is a nested for loop function that we have. So the outer loop is going to count the passes. So recall, with the bubble sort, we made several passes through the data. So this outer loop is going to be the one that controls how many passes we have. And as I mentioned before, the number of passes that we make is equal to actually elements minus 1. So if I send in 100, it's going to do 99 passes through that data. So it's going to do a lot of passes. So the outer loop controls the passes. Now the inner loop is the one that moves down one index at a time, and it compares the adjacent elements in the list. So we have an index j. It starts with 0, and it goes down to elements minus 1. So remember, when we get to the bottom, we are comparing two numbers together. So we don't need to go to the very end of the list here. We go to elements minus 1, and then that compares the last two elements in the list. And now we have the if statement. So if the number located in index j, if it's greater than the index j plus 1, then we want to move the element at j plus 1 up. So we want to swap those. Okay, so if, for example, the number at index 7 is greater than at index 8, then we want to move 8 up and 7 down. So here are the lines of code to do that. When we're swapping elements in an array, we have to pull one out and hold it temporarily. Then we are going to reset the value at index number j, and we'll just move our j plus 1 value up. So that would be like moving up into index 7, whatever is at index 8, or moving up into index 6, whatever is at index 7. So you get the idea. Then when we move that up, we can set the index at j plus 1 to the value at hold. So this is just the 3 lines you need whenever you're swapping two numbers in an array. I'm going to count how many swaps take place because I'm going to compare it to our selection sort coming up. So I have a counter in here so that whenever we swap two numbers, I'm just going to update that counter, and the counter starts at 0. So when we finish the two loops, we have the inner loop that's doing the pairwise comparisons, the outer loop that's doing all the passes. Then I'm going to output how many counts. I'll output how many counts we had during the sort, and then we return. So here's a function, and I made it a function because sorting is something that you would need to do over and over again. So let's, anytime we have code that we want to reuse, then we need to make it into a function. Now, that does it. Let's go ahead and set our prototype. So I'll copy the first line. We'll go up to the top and I'll add it to our prototypes up there, put a semicolon. Then when we want to do the sorting, we just have to call the bubble sort right here. So we'll put in the line of code to call the bubble sort, and we'll pass it array. Okay, so here is the call. We just call bubble sort. We send it array 1, and it contains the constant size number of elements. So this program, then, we will initialize the array and we'll print out the unsorted data. We'll do that with this call to print array here. Then we'll call bubble sort to sort the data. We'll call print array again to print out the sorted information. So now let's compile this program and let's run, and we'll see how bubble sort works. Now the program is running and we have the output. Okay, so let's just look at the unsorted data. Okay, so here we have 100 numbers. They're just numbers between 0 and 99, so you've seen this before. So here's the unsorted data. Then we have the sorted data below. Now in this case, we had 100 numbers, and the number of exchanges were 2,609 for this particular set of random two-digit numbers. At the bottom, you can see that after we have sorted them, then the numbers really are in sorted order. So 0, 1, 2, 3, all the way up to 99 on the bottom. So this illustrates then how we can sort an array of integer values using the bubble sort. Now, in the case of other types of data, then you can sort that as well. And in this case, the bubble sort is expecting an integer type, but this could be anything. You could sort floats, you could sort doubles, and even strings. So if we needed to sort words that were going into our dictionary, we could sort strings here as well. The only thing we need to be careful about is when we change the type of the array we're sending in, we also have to change the type of that hold variable that we're using in the swap line down here. Now, that shows you how to do the bubble sort, but there's something else I want to show you. It's kind of a detour here for this program, and that's the function that's generating the random numbers. Now, you may wonder why, when we use this random number generator, we always get the same numbers. They are reproducible. When you use rand by itself, it generates a random number from 0 to 32,000 something, and we limit that to 0 to 99 by using this modulus operator. But is it really random if it gives us the same set of numbers over and over again? Well, yes and no. I mean, the numbers, they are random, but they are repeatable. If you would like to generate random numbers that are not repeatable, then you can do this. So let me show you how to do that. We will need to include another compiler directive, another library in order to do that. So you could put that at the top of the program, or you can put it right here. So let me show you what that is. Okay, I'm going to I'll paste in this code. So I'm going to include this thing called time.h. The .h is there, and as I mentioned way back at the beginning, you can use the old C libraries with C++, and you can tell them apart because the .h means we're using one of the original old C libraries. So this is going to allow us to access the time, that is the system time that your computer has. Everyone has a system time. So we're going to use that. And we are going to do something called seeding SEED, seeding the random number generator. To do that, we call a function called srand. So I'll paste that here inside our initialization function init array. So the srand function, and you can put any number here you want. Okay, so if I wanted to remove the time, then you could put a number here, like 17 or 12, whatever it might be, and that would seed the random number generator. But again, it would be repeatable. If you always use this same seed, then the set of random numbers is always going to be the same set of numbers. So what we'd like to do is to put something here that is a different number every time we run the program. And time is one way to do that. When we use the function time, that gives us actually an extremely large integer value, which is the number of seconds since a given time. And that changes every time the clock ticks. So each time we call this init array function, then time is going to be moving on and give you a different number. So if you want to truly have non-repeatable random numbers, then this is the way you do it. Use the srand seed function in conjunction with the time library here. And that ensures a generation of non-repeatable random numbers. Now that we've taken a look at the bubble sort, let's bring in the other sort, the selection sort. And I could do a new program, but we have everything we need here. So I am just going to add in the selection sort as a function below the bubble sort. And instead of calling the bubble sort this time, we'll call the selection sort. So again, you don't have to memorize the code for these. They're readily available, and you may even see variations of the code. So down here, let's add a function, and I'm just going to add a comment, the selection sort, to indicate what we're doing here. And I'm just going to go ahead and paste in the entire function. And then let's go through the function and let's take a look at the code. Now, I want to bring over the diagram again. And remember, with the selection sort, each time we go through a pass, we only swap two numbers. You find the smallest number, and then you move it up to the top of the list. And each time you make a pass, then the list gets shorter each time because you've placed the minimum value at the top. So each time we make a pass through, we put a number in its final location, and the list continues to get shorter. But we only make one swap, whereas in the bubble sort, you could make a lot of swaps as you go through each pass. Now, let's look at the code for that. So we have the selection sort, and it's exactly the same as far as the formal parameters are concerned. That looks the same. And we have the double for loop, the nested for loop again. And the outside for loop also is the same as we had with the bubble sort, because we do have to go through every number in the list. So that's what the outside loop does. It goes through every number in the list, so the pass is going to be the same as the number of values that we have. Now, inside though, the inside for loop is a bit different because we're not just swapping the numbers pairwise as we go down. We want to start out by finding the index of the smallest number, and we're going to swap that with the element at the very top, and we'll use pass for that. Okay, so we're going to start at index 0 the very first time, and that's because we want to move the number, the smallest number, up to index number 0. So 1 will end up there. So we'll start with that. So that will be set to the index of the smallest. Then the loop that's inside, this inner for loop, that loop just finds the index of the smallest number. So when it's finished, then the index of the smallest will be known. Then we can use that to do the swaps down here. So we just use the same 3 lines that we had in the bubble sort, and we're going to swap two numbers. So the small number at the index of the smallest number is going to be placed up to at the top, and then we're going to move the number that was up at the top down. And we're going to count how many swaps there were. All right, so notice again, the for loop, the internal for loop, it just has that much right there. And the swapping takes place in the outer loop, not the inner loop, as with the bubble sort. So if we go up to the bubble sort here, then you can see that the actual swapping takes place inside the inner loop in the bubble sort, and it does not in the selection sort. All right, so that's the code, and it, like I said, it looks very similar, and we'll print out how many exchanges were made. So we'll compare that to the bubble sort. To finish this, we need to make our prototype. So let's copy our first line of the selection sort. Let's paste it up at the top where prototypes go to live. And then I've already changed that comment there, so we're going to print out the selection sort here instead of the bubble sort. All right, let's see. So we have the original data, we print that out, and here we call the bubble sort. Okay, well, let's just change that. Instead of calling it the bubble sort, let's call the function the selection sort. And I guess we should comment this out too, or change the comment. Okay, just to be consistent. So now, the only thing I've done is I'm just replacing the call to the bubble sort with the call to the selection sort. So the arguments are the same. Then, when we're finished with that, the function returns and we'll print out the sorted array. Now let's compile this program and run it. Let's look at the output. So we're doing the selection sort this time. So we have our random number generator produce, in this case, some non-repeatable numbers because we introduced the srand seeding function in our init array function. So here's the original data. And then we have the sorted data here. So you can see that that is indeed sorted. But notice that we had 99 element exchanges in the case of the selection sort. And if you look back at the one we did with the bubble sort, it took over 2,000 exchanges to do its job. So there you go. Those are two sorting algorithms. They're classics. They're always introduced when we're talking about searching and sorting in computer science. And I guess it's kind of a tradition. You know, the bubble sort is not very efficient, and this points it out. So the bubble sort is a classic sorting, but it's one that generally is used to show you that you can have a sorting program that works, but it can be very inefficient, and there are better choices, including the selection sort, which is much more efficient in sorting things. Also, you don't have to sort integers all the time. In the sorting algorithms, you know, here's our bubble sort, and here is our selection sort. Then I've made those integers, but the data that you sort could be anything. You can have a float, a double, or you could have strings that you can sort using this. So you could just modify these functions a little bit by changing this type, and you can sort any kind of data that you want. Before I end this video, I do want to show you some of the resources that come with C++, because we certainly are not finished with sorting and searching. So the algorithm library that comes with all C++ compilers has a tremendous variety and selection of things that you can use that are already pre-programmed, so you may want to check these things out. Under the algorithm library, we can scroll down and we can look at various categories of things, and one you'll see here is sorting. So under the sorting category, you'll see we have a number of sorting options here. 1, 2, 3, 4, 5, 6. There are 7 sorting techniques that come with C++, and there are several versions of the binary search that you can use. So you can see those here, and there are some merge sorts as well. So this does a sorting of different files that you can bring together, and it sorts them as well. So I just wanted to point this out, that when you go out and buy your C++ compiler or wherever you may get it, it comes with a tremendous library of built-in functions that you can use. So as you go forward in your career and you run across something that you might need, then go check out these libraries, because it's likely that there might be something there already that you can use instead of having to code it from scratch. If you're interested, there also are a number of entertaining videos on YouTube, just go there and do a search on sorting algorithms visualized, and you'll get quite a selection of things that some are entertaining, and some are a bit more involved, showing you code and everything. But here's our little example of our bubble sort robot that's sorting different colored balls. So you see he's comparing them pairwise and moving them up to the top. So that's just an example. There are quite a few, and like I said, if you want to be entertained a little bit and maybe do some analysis on sorting, then just go to YouTube and find some of these videos. Anyway, that does it for us. So this completes our topic of sorting and searching. So we did the binary search earlier, and now we've done these two sorting algorithms, and that will be the extent of our sorting and searching in this course. So let's stop the video here.